Hi, this is Alex from devstories.eu, Mastering Modern Pandas, Episode 6 of 8. You probably think grouping data is just about rolling up numbers to find a total or an average. But what if you need to evaluate a single row based on the behavior of the group it belongs to without losing the original shape of your dataset? This requires moving beyond simple summaries and using the split, apply, combine pattern. When you call a GroupBy method in Pandas, you trigger a sequential three-step process. First is the split. Pandas takes your entire dataset and divides it into independent groups based on a key you provide. Next is the apply step, where a function is executed against each group entirely independent of the others. Finally, the combine step takes the results from every group and stitches them back together into a single data structure. Many developers think the apply step is strictly for aggregation. Aggregation takes a group of values and returns a single number, like the sum or the mean. If you group a customer support dataset by agent and ask for the average resolution time, you get a new dataset with one row per agent. That is useful, but it is only 1/3 of the story. Here's the key insight. The apply step is just as frequently used for transformation and filtration. A transformation performs a calculation on the group but returns an object that is indexed exactly like the original data. It does not reduce the row count. Let us go back to our customer support dataset. You want to know if a specific ticket took unusually long to resolve, but an unusual time for a junior agent might be a normal time for a senior agent handling highly complex issues. You need the z-score of the resolution time relative only to that specific agent's historical average. You split the data by agent and apply a transformation function that calculates the z-score. Pandas calculates the mean and standard deviation for agent A, standardizes agent A's tickets, does the exact same for agent B, and then combines them. You get your original dataset back, row for row, but now every ticket has a standardized score based strictly on its specific group context. The third core application is filtration. This lets you discard entire groups based on a collective property rather than evaluating individual rows. Suppose you want to analyze those ticket z-scores, but some agents in your dataset only processed 2 or 3 tickets. Their averages are statistically meaningless. You can use a filter function on your grouped object to check the size of each group. If a group has fewer than 10 tickets, the filter logic returns false, and Pandas drops every single row belonging to that agent. The combine step then returns a dataset containing only the tickets from agents with a valid sample size. You split the data by a key, apply a logic rule that evaluates the group, and combine the survivors. Aggregation reduces data. Transformation standardizes data within its local context. Filtration discards data based on group rules. The true power of the split, apply, combine pattern is that it allows you to manipulate individual rows using group-level context without ever writing a manual loop. If you find these deep dives helpful and want to support the show, you can search for devstories.eu on Patreon. I would like to take a moment to thank you for listening. It helps us a lot. Have a great one.